Okay, everything's good. Alrighty, I'm recording. Okay, so module 7 is kind of a really big departure from like what we've been doing with all of the acid bases, equilibrium, and KSP. There's like a little part of it that deals with equilibrium, which we'll talk about later, but now we're kind of like shifting gears a bit with the math that we're doing. Um, and so yeah, like you don't really need to know this. This is just like building off of like what we've learned, right? Um, so this is important. So spontaneous thing is something that will happen naturally. It will happen like favorably, basically. Like it's going to occur. So like an example that I think about, I guess, is I mean, yeah, like ice melting, right? Ice melting in like at room temperature, it's a spontaneous process, right? At room temperature, which is around 25 degrees Celsius, ice will melt and form liquid. Um, or it'll be solid. Can I erase? Where's the eraser? Oh, there it is. Okay. So from solid to liquid, this is spontaneous, right? So if it's something spontaneous, something you guys need to be familiar with is that it will have a negative delta G, right? Negative delta G just means like, don't think of it like just think of the negative sign as being spontaneous. Think of the positive sign for negative for delta G as being non-spontaneous. So negative delta G is non-spontaneous. Or sorry, negative delta, yikes. Negative delta G is spontaneous. And positive delta G is non-spontaneous. All right, so yeah, if you guys are having trouble just remembering that, I suggest you guys would write that down. And so now he talks about this idea of entropy, and entropy is kind of like he really yapped a lot about it. All you have to know is that it basically describes like the disorder or chaos of any system. So the idea is that um yeah, like if you have multiple things like in the system, you can arrange it in any sort of kind of way. That means you have more entropy, if that makes sense. You don't really need to really understand like the whole like card thing or the domino sort of thing. Um, what you do need to understand, I guess, is these different rules with entropy, right? So entropy increases as you go from um, solid liquid to gas. So gas would have the highest entropy, and this would make sense, right? Entropy is like, I guess, like the way that molecules are positioned, right? So if it's in a gaseous state, it can be positioned in like an infinite amount of ways. Whereas if it's a solid, right, it's going to be stuck in like that specific position, right? So that is why that makes sense. And then likewise with a mixture can have multiple different positions, right? There could be like it's hard to describe it, but like think of like sand, right? If you have like sand with like multiple different sort of compounds in that, like it can end up in like a bunch of different things. Versus like a pure substance, like say sugar, right? Where even though like the molecules might be in a different position, there's not like a unique combination. They're all sugar compounds. So like just make sure if you don't understand it, just make sure you understand that rule up there. Temperature, this should make sense, right? Temperature is the average kinetic energy of a substance. We learned that last semester. So as you increase temperature, you increase like the kinetic energy, and therefore you increase like the range that a molecule can basically move. Um, and then likewise with pressure, right? Uh, I mean, this, yeah, like as you increase pressure or decrease pressure, increase volume, right? You increase the possibilities, right? The space that can move basically. And likewise, if you decrease pressure, or sorry, if you increase pressure or decrease volume, you decrease the possibility of entropy. Uh, and then the gaseous state, right? Things that react and form gas molecules, right? That's going to favor entropy. Um, And then yeah, over here, this is like, yeah, if you increase the molar mass, that'll also increase entropy because you're increasing in like a ton of electrons and protons and neutrons, right? And likewise, if you increase in the number of atoms, that also increases entropy. So like these kind of ideas could possibly be asked like on an exam, and that's why I'm kind of going over that. Yeah, is there any like questions about this? I feel like a lot of it is a little bit like, I guess like intuitive. I mean, at least for me, because I've done it for the last 3 years or so. But if it's not, like, try to write it out, try to maybe understand why those kind of things are the way that they are. Um, Usually for me, I don't really understand at first. First, I write it out, I memorize like what's going on, and then I like doing questions. I eventually understand it, I guess. So now it's kind of locked in my brain. Okay, but yeah. So, here's a practice problem. Which of the following causes entropy to decrease? What do you guys think the answer is? Yeah, B. All right. Does that make sense? It's just like based off the rules. And so likewise, you might be given, you're probably going to be given a question regarding reactions. This is like a very easy kind of question. Um, Obviously, we talked about as you like have more gas with pools, right? You're increasing in entropy. So like, for instance, something like E, for example, where you're creating a gas pool, this reaction here is having an increase in entropy. Um, on the other hand, for F, because if there, like this goes from 3 moles of gas to 2 moles of gas, it's gonna have a decrease in entropy. Uh, and so yeah, like I guess keeping in mind that rule that we talked about before will help you with these kind of questions. All right. Is there any questions regarding these kind of questions? Anything? Yeah. No, like no. Like when it comes to like the molar mass or whatever, like a question that they would ask is like they'll ask like which of the following has the right entropy, like the most amount of entropy, and then they'll give you like A is like 10 grams of CO2, B would be like 100 grams of carbon, right? Or they would make it a lot easier to like compare the two. So like they probably would just use CO2. They probably wouldn't use like molar mass versus like they would want to like test one of those kind of things. Or likewise, instead of it being like different kinds of masses, they could do like the same amount of mass but different molar masses. So like they could do like argon. B would be like 10 grams of like NO2, right? So like that's how they would test like that atoms or molar masses. They wouldn't do it in a reaction. Okay, so this is also important. So delta S of the system, right, is the reaction itself. Delta S of the surroundings is everything outside the reaction. And then delta S, like these two things added to one another is equal to delta S universe. You don't really need to know the delta S universe, but it's basically just equal to the system plus the surroundings. Um, and so yeah, like with the like an endothermic process, the delta S system would be positive, and then the surroundings would be negative. Um, yeah, and that I guess like, yeah, I personally don't really memorize. I don't really understand it fully myself. I just kind of memorize the chart. Hard to figure that out, but there might be a question about this. Um, okay, so yeah, so this is like a kind of question you could see about this. So yeah, I would say like try to memorize that chart. That's really important. All right. What do you guys think the answer is here? Okay. Uh, when you look here, right, it says that delta S is positive and then, or delta S of system is positive and the surroundings is negative. So if that's the case, then the answer would be A, because delta S of surroundings is negative, and then delta S of system is positive. So that's why we want to make sure you're familiar with that. But yeah, it's just basically if you know it, you know it. If you don't, you're kind of cooked. So that's why I'd say just memorize that chart. And now we get into the law of thermodynamics. Oh yeah, this is like the formula that I was saying. I don't know why I forgot about that. But yeah, so you want to just make sure you're familiar with this. Um, yeah, so anytime you have a universe, like delta S universe is positive, that means it's always spontaneous. But depending on like, yeah, like these two things, um, yeah, you'll see that it's sort of thing kind of changes. So this could be a kind of question you could also ask. I feel bad for just saying it all the time, but like these are like I guess like the small little like concept questions that you could ask. So just make sure that you're familiar with this. I think it's like kind of intuitive. When it's spontaneous, right? It's always when delta S is positive or delta S universe is positive, right? Um, and so if you look at this reaction or this equation, right? If this is positive and this is negative, the system has to have a greater magnitude than the surroundings in order for the delta S universe to be spontaneous or positive. And that makes sense, right? Like if this is one and this is one, delta S universe will be zero, right? Because it'd be plus one and then minus one, right? Because it's negative, right? But let's say instead of that, delta system is two, right? If it's plus two and then negative one, delta S universe will equal plus one, right? So like you can kind of like intuitively like figure things out like that. If that makes sense. Does that make sense to you guys? A little bit? It's just like you plug into the reaction and you see which one's which, right? If you know that this is if the system is positive and the surroundings is negative, then like and they ask like at what point is this reaction gonna be spontaneous? You could like see like, oh yeah, this has to have a greater magnitude than this, basically. And then likewise, if you see that this is negative and this is positive, the surroundings would have to have a greater magnitude than the system in order for like this to be positive. Okay. But yeah, even if you can't like intuitively see that, I'd say just like make sure you know this chart as well. Um, but yeah. Okay. Okay. All right. Which circumstance would cause a spontaneous reaction? Alrighty. What do you guys think the answer is here? Yeah, D, right? That would be the case where it would always be a spontaneous process. So that's right. Good. All right. Um, I guess yeah, like make sure you guys also know the laws of thermodynamics. I know it's like I kind of glossed over it, but you could also ask like some kind of questions regarding that. Also, like it's good for the cat kind of. There could be a question about it, which is silly in my opinion, but still. But anyways, like this is what's really important. With like delta H, we talked about this last year or last semester. Like Hess's law, right? Products minus reactants. The same thing applies with delta S, right? If you have the entropy of the products and the entropy of the reactants, you can get the delta S of the overall reaction. And so yeah, you can like I guess also know that. I don't know. Okay. Yeah, like yeah, make sure you also know like how these standard entropys are, I guess like formed, just like know that standard. It's not so bad, but yeah. And then yeah, you just have to know how to solve these kind of things. It's very similar to Hess's law, where you take products minus reactants. Right? Is it? I don't know, but the products minus reactants is the thing that we talked about last time. So yeah, like for this kind of question, you take products minus reactants, right? 2 moles of carbon dioxide. Make sure you pick the right carbon dioxide. Plus water, right? 4 times this. And then put all that in parentheses. So let me do this quickly, right? So 4 times CO2 plus, or yikes, this is 2, plus 4 times H2O minus 2 times CH3COH and plus 3O2. All right, and then you just plug in the numbers. You make sure you're using the right values, right? So this is here, it's gonna go there. This H2O is liquid, so make sure you use the liquid amount, right? Don't use the gas. He'll add like things that look similar. This one will go right, and then this guy will go over here, right? And then you just plug in the values and you solve. Yeah, so it's just kind of like product minus react. Make sure you guys are familiar with that formula. Okay. So yeah, like with this react question, try to solve for the delta H and the delta S. I'll give you guys some time for this one. Also, don't worry that this reaction is not balanced. No, I actually think that this question, I think this question actually might like, you don't actually need the water, but I added This as an because this is just dissolving, right? But just consider like water table react. All right, you guys did it? You guys good? Okay. So it's really important that you guys just make sure you guys don't make mistakes with this because the math is not that bad. It's just I think sometimes we can get a little tricked up with what we're doing and putting into the calculator. So just make sure you guys are practicing how to do this. So products minus reactants, right? So it's going to be I'm gonna do a delta S first, right? We're gonna have ammonium plus nitrate, right? And I'll put this in the parentheses minus ammonium nitrate plus let me write this 69.91, right? And I got a value of yikes, I need to charge I need to add my calculator is like dead. This was like 38.91, I think, right? And then this is joules per mole Kelvin, right? You want to make sure you remember those units. Delta H here is going to be the same sort of thing, right? Where it's going to be oh yikes. Hello. Equal to negative 132.51 plus negative 205.0, close parentheses, minus negative 286 plus negative 365.56. And I got 314.05. Is that what you guys got? So does this make sense, right? Yes, like delta S, for sure it does make sense, right? It's a positive delta S value. You're going from solid to aqueous, right? Yeah, like the way I would rank it, it would be like solid, liquid, aqueous, and then gas in terms of like entropy. Right. Anyways, delta H, that also makes sense. And the only reason why it makes sense to me is because I think like in the lab you guys actually dissolved sodium nitrate or ammonium nitrate once. And it was an endothermic process. That's something that I'm just like I'm familiar with because like that's an example regarding that. But yeah, like you wouldn't like be able to fully understand that based off the question, but yeah, if you do the math right, you would see that it's an endothermic process. Okay, so I didn't really solve it there, but all right. So yeah, is there any questions regarding any of that? Okay. So now we're gonna get into the important stuff, right? So delta G. Delta G is the measure of something that's spontaneous, right? So delta G, if it's a negative value, it's gonna be spontaneous. If it's positive, it's gonna be non-spontaneous. And this is a reaction that is here. I don't really have a good mnemonic for this. Do you guys have any good mnemonic? I just came up with one actually. Hot, hot ass. Yikes. I mean, it's not the best thing, but or you could just say hots. That makes more sense, right? Hots. Delta G equals hots, right? Like you just need to make sure you know that there's that like subtraction sign, right? Delta G, um, yeah, hots. Okay, don't think of hot ass. That's my bad. Um, but yeah, big takeaway, right? You want like this whole like react like module is all based off like how you can like understand the reaction, right? If you know the reaction, you're able to figure out a lot of the different like tables and graphs that we were talking about, right? So in order for like delta G to be negative, right, we would need to have this delta H be a negative number, and then this delta S be a positive number, right? In order for this to fully be negative. And that makes sense, right? If this was a negative number and you're adding like another negative number, you're gonna get another negative number. Now, if delta H is positive, right, and delta S is positive, you're going to need to have a higher temperature because this magnitude or this number with T delta S needs to be bigger than this positive delta H value. Okay? Why I'm like verbally explaining this is because like on the exam, you might not be able to like write out the full table, right? But if you have the formula, you're able to figure out these kind of concepts that we might ask about, right? So let me just like write this out a little bit. So like negative, this is always positive or negative. Like this is always spontaneous. If it's positive and negative, or sorry, if this is positive and positive, um, you need a higher temperature, right? Because you need to have this magnitude be bigger than this one. Oh, sorry. Oh, wait, my bad. This is not good. Wait, it's negative and positive. My fault, right? So if delta H is negative and this entropy is positive, right? You're always gonna have a spontaneous thing. If delta H is positive and delta S is positive, only at higher temperatures will it be spontaneous. All right. And likewise, if delta H is negative, and delta S is positive, it's only gonna be at lower temperatures. All right, and that makes sense, right? Um, if this is a negative number and this is also a negative number, right? If this magnitude like is less than this, it's going to end up being negative at a lower temperature. So like if T is like 0.01, right? That negative value is going to be negligible in comparison to like that negative delta H value, if that makes sense. But even if you don't understand it, you have the formula to like make sure you understand it at some point. And likewise, if you have positive and negative, it's not spontaneous. Or like a big X, right? Not gonna be spontaneous. But yeah, just like from this formula, you can like figure out that whole chart that we're gonna talk about in a second. Okay? But yeah, does this like make sense a little bit? It's just like their like equation that's like what you really need to know. This is really good for like the MCAT because they get asked this kind of question. And this question can be like, boom, like, oh yeah, just write out these different ideas and then that will help you with the concept. So like this is exactly what we just went over, right? Yeah, like I wouldn't expect you guys to like memorize this, but like you should try to like understand the formula so that you can get this sort of information. This looks like a lot of information, but this information here is literally the same thing as this. Like you don't need to memorize this if you know how to like write out this like on your exam. Like this will take like 30 seconds to write out if you like understand how like you get a spontaneous reaction. Okay? So, okay. With the delta H's and delta S's that you found, let me write them out. Delta H was um 314.05 and delta S, this is kilojoules per mole Kelvin, and delta S was 38.81 joules per mole Kelvin, right? With these two values, try to solve for delta G at 25 degrees Celsius. Make sure that you convert the Celsius to Kelvin, and yeah, you guys can figure that out. I'll give you guys some time to do that. All right, you guys good with this? Okay, so the big like trick with this question is that delta S and delta H are in different values. Delta S is in joules and delta H is in kilojoules. So you want to make sure you convert one or the other. I would recommend just converting to kilojoules because you always see like delta G in kilojoules. But either way, like you should get the right answer at the end of the day. So with converting joules to kilojoules, like what I used to do when I like first like was like trying to get used to like chemistry and stuff is I used to literally do the dimensional analysis. So like for every like as you know, like for every 1 kilojoule, there is 1,000 joules, right? So I would literally do like 1,000 joules over 1 kilojoule, just so that I like make sure I'm doing the right thing. Because sometimes you like if you, for me at least, like I could make that like mistake of like converting it the wrong way. Um, but yeah, as you get comfortable, you'll know that it's just two like you just yeah, you have to add the two zeros there and then 3881 kJ per mole Kelvin. Okay. So then after that, now you just plug in, right? I would recommend with all these formulas, I know it's going to probably be on the reference table. It's really important to memorize them though, just because on the S like MCAT, you're going to need to know the formulas. Okay, so then you just plug in the numbers. So 314.05 minus now 25 degrees Celsius plus 273.15 is like 298.15 Kelvin. It's common. And then this is 0.003881. Okay. I added an extra zero. Did I? Oh yeah, I did. Oh, my bad. See, this is why I do the dimensional analysis, right? So then when I put in the calculator, I won't get the wrong answer. I'll just get the right thing. Um, Thanks for catching that. So yeah, don't go off your gut. Like if yeah, like if I'm like if you're comfortable with doing it, whatever, but I'm not comfortable. That's why I don't. So 314 minus going to 302. Yeah. Okay. 300. 302.48. Okay, sound good? So this is in kilojoules per mole. So is this reaction spontaneous? No, it's not spontaneous because it's a positive value. So you want to just be familiar with this kind of question, right? Yeah. So yeah, with yeah, this is the same kind of question. So yeah, when you hear delta G naught versus delta G on its own, delta G naught describes the reaction at 1 atm and 25 degrees Celsius. Bye-bye. So yeah, just want to make sure you make sure you know that. Because yeah, they could give you delta G, um, and it's not at like those two things, right? So you want to make sure you know that, because it's going to be important for the formula later. So yeah, they could ask like, what does delta G not represent? Um, and you can figure that out, right? That's just the describes the free energy or spontaneity of a process under standard conditions, which is 1 atm, 25 degrees Celsius. Um, this is Hess's law again, right? Where you just basically flip the reactions to figure out the delta G value. Um, yeah, like if it says diamond and graphite, you make sure you like it's diamond and then is the reactant and then graphite's the product, which is what we talked about in class. Um, and then yeah, over here you just do the same thing that we did in doing products minus reactants, and then you figure out the delta G is equal to delta H minus T delta S. And then yeah, we could do this practice question. Let's try to do this one. So again, it's like kind of repeating the same ideas that we've been talking about. Yeah. Uh, what do you think? Yeah, it is C. I got C as well. You want to make sure you just be familiar with the formula, plug it in properly. I know that there was not really a lot of questions regarding like products minus reactants and using the coefficients. But there's definitely going to be a question regarding products minus reactants, making sure you use the right coefficients. Um, so yeah, like where is it? Like uh there's definitely gonna be a question. So that's why I'm just like emphasizing that. Um, yeah, these are like not that bad of questions, right? And so now we're going to talk about equilibrium and free energy. So, um, yeah, like equilibrium and free energy kind of they're not like going hand in hand, but there's some like relatability in some cases, right? Like, I do like this example of like the ball rolling down, right? Like, if you just have reactants initially, right, that delta G value of the forward reaction is going to be extremely negative. But then as you like get closer and closer to equilibrium, right, that delta G value becomes close to zero, right? And eventually it is zero because you're not creating more products and like products and react like the rate of the forward reaction equals the rate of the reverse reaction, and the like concentration of products and reactants are constant, right? Those are the two concepts that we learned last exam. Um, and so yeah, there's like the formula regarding this, right? So with the delta G naught, right, at 25 degrees Celsius and 1 atm, if you do plus RT natural log of Q is the equilibrium quotient, um, you can get delta G, which is the thing at non-standard conditions. And so, yeah, R is a very interesting number. R is going to represent 8.314 joules over Kelvin. Yeah, you want to make sure you're familiar with that. Uh, yeah, so because it's 8.314 joules, sometimes you want to convert that to kilojoules, right? So you want to make sure you're aware of that because delta G is usually kilojoules. Uh, and yeah, that specifically at times where it's at equilibrium, the delta G in general is going to equal zero, right? The delta G without the mass level equals to zero. So because of that, you can just move things around and make delta G not equal to negative RT, the natural log of Q. And this is really good for like figuring out questions and things like that. And so on the bottom here, I also have like how you could solve for K in this case. Because at equilibrium, Q becomes K, right? And so you can solve for K if you know that the system is at equilibrium and you know the delta G naught, and then you just plug in the value in terms of K. Okay? So like that's like some good problem solving that you could like encounter on the exam, where they might give you like this is probably the most complicated question you could get on like uh module 7, right? They tell you like, oh yeah, this is what reaction to equilibrium. Here's the delta G naught, here's the temperature, and yeah, they're asking you to find K. So like that's probably the most complicated kind of question. But yeah, do you have any questions about that? Yeah, it's not super bad. You just want to make sure you're familiar with the formula. There's not really an easy way to remember this either. So yeah, it's on the reference table too. But I don't know if this formula is on the reference table, like the one that I wrote here. That's just like kind of intuitive as well. So just make sure you know that. Shoo. Um, yeah, so this kind of question, they're asking you to solve for delta G and they're given the pressures and you just use the pressures to figure out Q. Um, okay. So this is a good question. So this is part one of the question. So I want you to try to do this one. Yeah, so it's asking you to figure out delta H value. So try to do that. Oh, we went to go. No, no, that was fun though. But yeah, no, this time we're gonna, yeah, we're gonna go to special because like, you definitely check out Saturday night. It's literally like right there. You drive, right? When you don't drive, your parents driving. Oh, let's see. That's -283, is it? It is. Yeah, that makes sense, right? So it's like Hess's law. You combine the two, right, and you flip one of the reactions, right? Yeah. So yeah. Okay. Next part. This is a little bit of a harder question now. So there's a bunch of parts to this. Now they're asking you to figure out delta S, and they ask you to figure out delta G, and they ask if it's spontaneous, and then they ask you to figure out um, equilibrium. Okay. Q. Yeah. Yeah. How do you put this? Oh. Ah. Ah. It's okay. I probably wouldn't even look my website. Uh, yeah, I know last semester was so late. Last semester was like 5:30 to 7. Well, I appreciate you hanging out here instead of just hanging out somewhere else. Oh yeah, make sure you have like the reaction from last, like from part one, so you can answer B. Oh no! And then did he tell you? Oh. I wonder what's going to Prescience's mind with that. Did you verbally be like, oh? It's okay. Yeah, usually like if you you spend more than 5 minutes on a question, unless you like know how to solve it, you're spending a lot of time on solving it. Right? Usually, if you don't know how to solve it, you spend a lot of time on it. Best course options, things like that. You skip the question. So that, yeah, I figured it out. But it happens. I remember it happened with like that. And I just like I was just moved on. I when I get like in that mindset, I get so stuck if I get solve it. And then I waste so much time and then make careless mistakes on other. Yeah, I think for me, like mine, like because I always be careless. But I like but yeah, kind of, it's like where like a lot of the questions you know, like kind of like they're not really connected questions. Like they're based off the past, but they're not like based off the last question. Actually, this one. That's kind of how was my exam. Uh, Good ones. Good. Wow. Let's go. Last year at this time, I was crashing out. I was really like, oh my gosh. You just finished finals. Yeah, I had like 17 days after my final. The finals. It was okay. I think like like you always hear so many people like have something to it. Like that a lot. Like, I remember I would go to like my mom. I asked them. If it's like I go up to them in January, I'd be like, you guys have because I already signed up for the May date or whatever. Okay, so you guys have any tips. First thing they say, don't take it early. Wait, I already scheduled it till like May 31st. You know, it's $300 in schedule, so I think you commit to a day at date. Obviously you could reschedule and get a refund, but yeah, but they were just like really hate doing shit. Like I remember one person was like, "Oh yeah, I chose not to talk to anyone during the song." No, like you just got locked in and do it. You know, like I think like when I took it, I was kind of calm. Like at some point you have to become calm. Like when you take all the practice, like I had 6 practice events. You guys are gonna have 7 practice. 6 practice exams should be more than enough. Yeah, there's like practice exams that you take online.
Oh, I think like in a class.
No. Like on the AAMC website, like you can buy the practice exams. Those are like the gold, like those. That's like direct, like it's like my practice exam for each, right? Where it's like it's not like it should be similar to what a first uses like standard is, right? But you know,
8 hours. Content.
yeah,
That's great.
yeah.
You did all of it.
I did. But the thing is like I don't think I used all the research that I could use. I did all the exams. So basically, if I have like give you like a rundown, um, like first 3 months of second semester, second year, I was like not doing a great job studying. I would wake up at 5 a.m. and I would study in the morning. So I was a morning person. I'd sleep at 10 though. Like I wasn't like getting back sleep. Um, but yeah, it was like manageable to study in the beginning, but I was just like focused so much on the third party stuff. I got like Crit. I'm sure you're getting like a ton of ads about Crit maybe. Yeah, like you'll probably get it like next year or something like that. I don't know how they like figure out that you're taking the MCAT. They send you so many ads. Uh, and so I took it because it was like a self-paced like prep course. But man, it was so useless. I feel like it actually like man, it actually like ruined my like ability to speak cards. But I usually like that's the reading comprehension. Like, yeah, there's 4 sections of the MCAT. There's chemistry, physics. There's like the reading comprehension section, and then there's the biochemistry section, and then psych sociology. And like when I say chemistry, like it's like organic chemistry. Very much. I'm passing. I know, I didn't, that was my worst section. But,
Yeah, I don't know how you can put them on.
I know, it's kind of tough. I feel like I got worse because like when I took like the third party, they like made questions so much harder. And so because they made it so much harder, it just made me really less confident. And then I didn't really. So that's one advice. I would say not to focus so much on third party as like a basis for how you. And then yeah, after spring break, I kind of like pivoted. I like was crashing out a lot because like didn't really a lot. I think like some packs exams, but like they weren't like great. Like I was getting the 500, 500, 498, and I need to get a 507. So then I kind of pivoted. I stopped doing any of the third party stuff and I focused so much on like I do like it didn't really have so much, but I did the cars like question pack like on the A and C. And then I'd also try to do like this like psych sociology deck. Because like when you're taking sociology next semester, you're not gonna learn anything. So you need to like learn out like all psych and all sociology. Unless you take Emily Recibo, but her exams are hard. So it's like you want the hard teacher with like a hard first grade, or like you have to study a lot for it, or like easy teacher doesn't teach you anything, but you're kind of chilling during the semester. She's like all right. Like she's fine. She's probably like terrified as well, which isn't bad, but like versus someone like totally studying at home, like yeah, kind of tough. I'll tell you more after about this. Okay. So yeah, first thing is you want to calculate delta S naught. So make sure you know the reaction here. So here it is. So CO plus 1/2 O2 yields CO2. And they're very kind and they gave us all three of the values without any extra compounds on the exam. He'll probably give you extra compounds. So that's why I'm emphasizing that. So carbon dioxide, right? That's the product minus reactants. So 1/2 205.1 plus 197.7. Okay. Let me do that. 213.7 minus 1/2 205.1 plus 197.7. I got negative 86.55. And that makes sense, right? That makes sense because you're going from 1.5 gas moles to 1 gas mole. So it'd have a negative entropy. Does that make sense? Okay, good. So this is joules over mole Kelvin, and they're asking you to find the delta G. So you want to convert this to kilojoules, so 0.08655 kJ. This is 298 Kelvin. And then you have to subtract this with the delta H value that you found originally. So negative 283 kJ mole Kelvin. And then you solve. So negative 283 minus 298 times 0.08655. So I got negative 30879 or 38.79. Is that right? Or did I do something wrong? Gosh. I think I did. Maybe I did something wrong. Oh no. Wait. Wait. Oh, this is not, I did do something wrong. This is supposed to be negative. So that's why it's very important that you check your work. All right. So I got negative 257, right? So see, this is what I mean. I make a lot of careless mistakes. So like that's where a lot of my questions what I'll get wrong in. But I think the positive mindset that I would tell myself is that at least I understand how to do it. I'm just making a careless mistake, right? But still, is this reaction spontaneous? It is. It's negative. So now it's asking you to calculate the KEQ. And so you have the delta G naught, you have the temperature, and yeah, even though they're not telling you that delta, like the non-standard delta G value, you can assume that that's the case. And you could just do delta G naught is equal to negative RT natural log of K. Like you can just like make that assumption. They don't need to tell you what delta G is. Like if they say like what's the equilibrium constant, you assume that, and then you can use this equation. So with this, right? Yeah, you could do a couple things here, like just to make things easier. You could do what I wrote above, where like you put the E and like put everything in there, or you could like do this stepwise. So like you could do delta G over negative RT equals natural log of K, right? And then afterwards, after you find this value, then you do the like you put that to the E power. So like let's say that this is X, right? So right? Yeah. So we're gonna solve for this first value, and then we're gonna put that to the E power and then equal X. Okay. So let's do this. So negative 257.21 divided by negative 8.314 times 298. Okay, so I got 0.104-ish, right? That right? Oh, you didn't do that? Oh. Okay, and then e to this power, and I got 1.11 equals k. So like this here value is going to be 0.01, or sorry, this is 0.134, right? And then here it's going to equal k is equal to 1.109. Okay. And let's see if that's right. I didn't get it right. What did I do? Oh, it's in oh. Okay. This is where I made a mistake, right? So I didn't really explain anything, right? R, what's the value for R, right? R is 8.314 joules, right? It needs to be in kilojoules because delta G is in kilojoules. So that's where like you need to make sure you're doing this right. So yeah, like with this, yeah, it's kilo. So I need to divide, or let me fix that up. Let me actually write out what I'm doing because I'm like kind of verbalizing it without actually writing it. So let me do that. So 257 negative 257.21 over 0.008314 kilojoule per Kelvin times, and this is negative, times 298K. Okay, right? That makes sense? Okay, so now let me do that. Negative 257.21 divided by 0.008314 times negative 298. Okay, now I got 103.81, right? And then now you put e to the power of that, and then you get a big number. So e to the power of this number, you get 1.22 times 10 to the 45th power. Okay? Yeah, delta G standard is negative. So a good question you can ask yourself is like, does that K value make sense, right? If delta G is negative, that means that you're gonna have probably more products than reactants. Wait. Mhm. Oh, like for the formula that I do, I just like subtract this one. So instead of it being like negative, like instead of me bringing this one to this side, I bring this whole thing to that side. Like that's why this value here would be like negative. Like if you did, you could do the same thing here. Oh, it's yeah. Um, yeah, and then the K value makes sense because negative delta G means that the forward reaction is really favored. And so that's why there's more products than reactants. So if you had a non-spontaneous sort of thing, you're gonna have a K value that's less than 0. And that would make sense. So, yeah. Yeah, here's like the work for this. I emailed all you guys this stuff too, so you can check it out. And then yeah, that's pretty much that. One thing I would like to note, because I didn't think I kind of glossed over it a bit. Where is it? Is there any? I don't know if there's this. There probably was a slide about this, but comparing delta G with K, or can I zoom in? Okay. So when delta G equals 0, um, like the thing is at equilibrium. So like Q is equal to K in this case, right? Um, and then yeah, delta G is greater than 0. That means that yeah, like delta G is greater than 0. There's like a okay. I'm gonna come back to you. I have to think about what I'm gonna say here because I kind of forgot the important thing regarding Q, delta G and K. Let me see on the slides if there's anything. One second. Sorry. Do. Oh, I think it might be an Oh, it's in electrochemistry. Because then they really like voltage with like give like delta G and then K. So I'm kind of jumping ahead. Yeah, it's not on here. Okay. So yeah, disregard what I'm saying here. But yeah, that's pretty much the whole module. It's not really a long module. And module 8 is like I guess a little bit chunkier than module 7. That's why there's 3 days for it. But it should be good. But yeah, I'm gonna stop recording. Oop, wait. Oop.